Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at the MAC address table. We'll be discussing switch fundamentals, switch learning and forwarding. We're going to examine the source MAC address, we're going to find that destination MAC address, and then finally we'll talk about filtering frames. This episode is part of my series on Introduction to Networks for the Cisco Certified Networking Associate, or the CCNA. I'm Kevin. This is KevTechify. Let's get this adventure started. When a layer 2 switch uses a MAC address to make forwarded decisioning, it's unaware of what the actual data is itself. At this point, we are concerned with getting data from one Ethernet NIC to another Ethernet NIC. Whatever we're carrying, these forwarding decisions are based strictly on the MAC address. So whatever we're carrying in the back, what we've encapsulated, we don't care at this point. We're just concerned about looking at the MAC addresses and sending this information onto the next device. The switch examines the MAC address. Based upon that MAC address, it goes through a process of getting that frame to the next device. When the switch is turned on, there is no MAC address table. It is completely empty. It's stored in RAM. So if it loses power, it has to rebuild that MAC address table. The other thing to note is sometimes you'll hear people talking about the CAM table, the Content Addressable Memory table. What that is just another name for the MAC address table. So if you hear MAC address table or Content Addressable Memory, CAM table, MAC address table, they're equal to the same thing. When a frame comes into the switch, that switch looks at the source MAC address. And why we look at the source MAC address is because we know that frame came into a certain port on that switch, and now we can start building our MAC address table. We can see that MAC address, that source MAC address, came from that port. And now we look in our MAC address table. Does that MAC address exist in that table? If it does, then we forward on the frame. If it doesn't exist, we go ahead and we add that in. This MAC address is on this port. That entry is kept for 5 minutes. After 5 minutes, it's discarded. And if another frame comes through, it goes through the process of learning that again from that source MAC address. Now, if that source MAC address is on a different port, say somebody moved from port 1 to port 2 on the switch treats that as a new MAC address entry. It goes through the process of getting in that frame, looking at the source MAC address, looking in its MAC address table. If it exists in there, we update the port number. If it doesn't exist, we go ahead and add that in as a new entry. When a switch gets a frame in, it now has to forward it out. And so the forwarding out, if the forwarding out is to a unicast MAC address, not a special MAC address that represents a multicast or a broadcast, but it goes to a single device, it looks in its MAC address table. If this destination MAC address is in the MAC address table, we then forward it out the port that we have stored in our MAC address table. If that MAC address isn't in our MAC address table, we forward that frame out of all the ports, except for the port it came into. This is an unknown unicast, and is part of the address resolution protocol, the ARP Lookup Process. If the destination MAC address is a broadcast or a multicast, the switch then forwards that frame out of all the ports, except for the port it received it in on. The switch filters frames. Now, when it filters frames, it gets the frame coming in, and so it comes in from PCA right here. We know that the source MAC address, which is listed right here in our frame, we go through, we check our MAC address table. If it's not in our MAC address table, we add it. And then we have to forward it. And if we look at it, we are forwarding it to the destination MAC address way over here on PCD. And so what the switch does is it takes that frame and only sends it out on port 4. Now, how did it know to send it out on port 4? What it did is it looked at its MAC address table and it found the matching destination MAC address in its MAC address table. Here is the matching MAC address. And in that MAC address table, it said that MAC address is connected into port 4. And so let's forward it to port 4 on the switch. Port 4 is connected to the destination PC. So it comes out and it goes to our destination PC, our destination NIC. I hope you're liking this episode on the MAC address table. If you have time, please leave a comment and let me know what you think about the MAC address table. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Let's look at an example on how switches build their MAC tables. In this example, we're going to send a piece of information from PCA to PCB. After we receive it, then we'll send a piece of information back from PCB to PCA. On PCA, we start with some information high in the OSI model. We start passing it down through the layers. It gets to layer 3. We build our IP packet. We then pass it down to layer 2. We add our frame header, our frame trailer on to make the complete frame. Once it's ready to send out, we send it out across our media to switch 1. Switch 1 receives that frame in. First thing switch 1 does is it looks at the source MAC address, the MAC address of where it came from, and then it compares that to its MAC address table. Do I have the source MAC address 000A in my MAC address table? Looks at the MAC address table. It is not in there. Let's create a new entry for this MAC address. We go ahead and enter port 1 that has the MAC address of 000A on there. Next thing we do is look at the destination MAC address. Destination MAC address is 00B. We look at switches 1 MAC addresses table. We look through there. Is 00B in there? Nope, 00B is not in there. What we do then is we forward that frame out of all other available ports that, except for the one we did not receive it in. If it's not in the MAC address table, we forward out all the ports on the switch we did not receive it in from. The frame gets forwarded out ports 3 and 4. When it gets forwarded out of port 3, it's sent down the media to PCB. PCB then looks at the destination MAC address. Destination MAC address is 00B. PCB MAC address is 00B. It is destined for PCB. PCB accepts it in and starts processing it up the OSI model. Meanwhile, it also got forwarded out of switch 1 port 4. When it goes out of switch 1 port 4, it goes into switch 2 port 1. First thing the switch does when it receives that frame in is look, the source MAC address of the frame, source MAC address is 00A. Looks in its own MAC address table. Do I have an entry for MAC address 00A? No, I do not. Let's create an entry. That entry stores the port information that it received it in. It received it in on port 1 on switch 2, and it puts the MAC address in there, 000A. Now, notice, we can look and see that if we go the other way, when switch 2 gets frame in destined for 00A, it doesn't necessarily forward it to its final destination. It forwards it to switch 1, then switch 1 can forward that to its final destination. But getting back to our example, switch 2 received that frame in, updated its MAC address table, then it looks at the destination MAC address. Destination MAC address, once again, is 00B. Looks in this MAC address table, it's not there. We forwarded out all available ports except for the one we got it into. Goes out port 2 down to PCC. PCC looks at the destination MAC address. Once again, destination MAC address is 000B. PCC's MAC address is 00C. Doesn't match. PCC discards that frame. Meanwhile, out of switch 2 port 4, we also forward that frame. It goes over to the router. The router receives it in. Now, the router is not a switch, so we don't have a MAC address table in there. Router 1 receives it in, looks at the destination MAC address. Destination MAC address of the frame, once again, is 00B. Router's MAC address is 00D. They don't match. Router discards that. That is how we built the MAC address table on this example. Let's take and now send a piece of information from PCB here and get it to PCA. PCB takes the information, passes it down the OSI model, gets to layer 3. We have the IP packet, we pass that down to layer 2. We encapsulate that with the header, which includes destination MAC address, source MAC address, puts the trailer on there, that frame check sequence that does the error checking, doesn't do error correction, but it does error checking, and then sends it down the wire. Switch 1 receives that in. First thing switch 1 does is it looks at the source MAC address of this new frame. The source MAC address is 00B. Looks at the MAC address table. Do I have an entry for 00B? No, I do not. Let's update our MAC address table by adding in this new record. Port 3 has the MAC address of 000B attached to it. Now that we've updated our MAC address table, we're going to look and see this destination MAC address. Destination MAC address is 00A. We look at our MAC address table. Do we know where MAC address 00A is? In the MAC address table, there is an entry for it. It is on port 1. Let's forward that frame out of port 1. We don't have to forward it out of any other ports because we have an entry for that, and we know that to get to MAC address 000A, we send it out port 1. We don't have to send it out of all the other ports. And then when PCA receives that, MAC address of PCA is 00A, destination MAC address is 00A. It matches. We can now start de-encapsulating it and processing it up the OSI model. We're going to take a look at a second example here. In this example, PCA is going to contact a computer not on our network. That computer is then going to send a response back. As we get the information, pass it down the OSI model, we build our packet. Once again, our destination IP address is not on our network. Now, in order to get off of our network, we have to go through the default gateway, which is our router. PCA gets the information, passes it down the OSI model, layer 3. We build our IP packet, we pass it down to layer 2. Looking here, the destination MAC address for our frame is our default gateway. That is on our router. That is how we get off of our network to somebody else's network. Our source MAC address, that is PCA right here. We build our frame, we send it on our wire. Send it out our wire to switch 1. Switch 1 gets it in on port 1. First thing switch 1 does is it looks at that frame. It looks at that frame, looks at the source MAC address, and says, is that source MAC address 00A in our MAC address table? Go up here, we look, and there it is. All it has to do at this point in time is reset that 5-minute timer. That 5-minute timer, if nobody uses that MAC address entry, the switch deletes it out. But because we're using it again, all it's going to do is reset that frame. Switch 1 then looks at the destination MAC address. Takes that destination MAC address of 000D, looks at its MAC address table. Do I know that destination MAC address table? It is not in my MAC address table at all. At this point in time, switch 1 then takes that frame and floods it out of all ports on the switch except for the port it came in. That frame goes out port 3 and port 4 because that's where we have connections. When it goes out of port 3, it goes down to PCB. PCB gets that, looks at the destination MAC address. Destination MAC address is 00D. PCB's MAC address is 00B. They don't match. PCB basically gets in the frame header, looks, sees there's not a match on MAC addresses, stops accepting the frame at that point in time, and then deletes what it has in there. Meanwhile, it went out port 4. Port 4 goes to switch 2. Switch 2 port 1 receives that frame in. First thing it does is look at the source MAC address. Source MAC address 00A, is that in my MAC address table? Sure enough, it is in my MAC address table right there. Switch 2, all it has to do is update that 5-minute timer, start that timer over again. Then, after we look in our MAC address table for the source MAC address, we now look at the destination MAC address. Destination MAC address is 00D. Look in the MAC address table, it is not in there. At this point in time, switch 2 forwards it out of all available ports except for the one it got it in on. That means it goes out of port 2 and port 4. Nothing is connected to port 3 at this point in time. Goes out port 2 down to PCC. PCC receives that beginning of the frame, looks at its MAC address. Its MAC address on PCC is 00C. Destination MAC address is 00D. Those do not match. PCC stops accepting the frame and deletes what it has received so far. Meanwhile, on switch 2 port 4, that frame is forwarded out. It goes to router, which is our default gateway. Here, it receives it on port 1, looks at it. Its MAC address here is 00D. Looks at the destination MAC address. Destination MAC address is 00D. It accepts it in, and then the router starts routing it to its final destination. That is how we look at our MAC address table. The final destination, the web server, receives that request in there, processes it, sends it back. Notice, we now have changed our IP packet here. The source IP address is now on the remote network because it's coming from that web server, way off, no matter wherever it is. It comes back in the router. The router gets it in. It looks at the frame. Looks at the frame, says it's not me. I'm going to forward it on. Forwards it on to switch 2. Switch 2 receives that frame in. First thing it does is it looks at the source MAC address. Source MAC address is of the router. Looks at its MAC address table. Do I have an entry for 00D? No, I do not. Let's add that entry. Port 4 is 00D. After we make that entry into the table, we now look at the destination MAC address. Destination MAC address of the frame is 00A. I look at my MAC address table. There it is. It is in my MAC address table. I know that MAC address 000A, I have to send that frame out of port 1. I go ahead, I send that frame out of port 1, and then switch 1 port 4 receives it in. Switch 1 port 4 receives it in. First thing switch 1 does when it gets that frame in, it looks and sees the source MAC address on that frame. Source MAC address on the frame is 00D, looks at its MAC address table. Do I have an entry for MAC address 00D? No, I do not. Let's create that entry in there. 00D MAC address is associated with port 4. Next thing we do is look at the destination MAC address. Destination MAC address is 00A. We look at S1's MAC address table. There is 00A right here, and that is to port 1. We go ahead, take that information, send it out, switch 1, port 1, goes down to PCA. PCA receives that frame in, looks at the destination MAC address, Destination MAC address is 00A. PCA's MAC address is 00A. They match. PCA continues and fully accepts that frame in. It was my pleasure to provide you with this wonderful episode on the MAC address table. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There, you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.